All right, so I think I'm live now. Can someone confirm? Compare recession is there. What a final year CC student should do when hardly any company is taking in interviews. Startup करते हैं, no cash, problem C is tough. Yeah, C is a little tough, I would say. Like implementation wise. हाँ, समझ आया. Okay. I still don't see anyone in the chat. I think there is some lag. Solid AV, Roy Lab says. Am I live also? Can someone confirm? Yes, you are live and audible. Okay, cool. All right, so let's wait for a minute or two for more people to join and then we'll start. Okay, we have 9 people. Yes, yes. How many problems were you all able to solve today? Let me know. I solved ABC. I'm trying to figure out like how to solve D. I tried for an hour. Not really. I'm not sure if I'm close as well. Became specialist today. Really nice, Kunal. Happy for you. 3. Okay. Mayank says 2. In C, we just have to check the number of distinct elements in V0, V0 and VI, right? No, that's not the case. ABC, only A and B. Okay. Okay. I'll be solving problem A, B, and C. D seems to be a little difficult. Even I haven't figured it out yet. So I'll be solving A, B, and C only. A and B are pretty simple. C is a little trickier, I would say. But yeah, even C is simpler. Okay. Should we start or should we wait? I think since it's an unusual timing, that's why less people are coming. And see, we just needed to check the contribution of each number from 1 to n plus m to the answer. Yes, yes. Good evening, Naman. Ors. Good evening. Okay, okay, let's start. I'll start with the very first problem. Hopefully, by the time we are done with A and B, most people would have joined. Okay, so let's see the very first problem, which is Serval and Mocha army. Mocha likes arrays, and Serval gave just a second. Mm, Okay. Alright, so vocalize arrays and Serval gave her an array consisting of positive integers as a gift. Vocal thinks that for an array of positive integer a, it is a good if the GCD of all the elements in a is no more than its length. Basically, it is a good array if the GCD of the entire array is less than or equal to the length of the array. Okay. After that, and for an array of at least 2 positive integers, it is beautiful if all the prefixes whose length is no less than 2 are good. So basically an array is beautiful if every prefix with size greater than 2 actually is a good array as well. Okay, so for example, 3 and 6 is not good because, let me just explain it like this. They are saying 3 and 6 is not good because GCD of 3 and 6 is 3, which is greater than its length. Obviously, that is why this is not good as well and beautiful as well. Okay. Now, in the next array, 1 to 4 is both good and beautiful because all of its prefixes whose length is no less than 2, which are 1, 2 and 1 to 4 are both good. Exactly. We had an array 1, 2 and 1 to 4 as prefixes. Both are good because 1, 2 has a GCD of 1, 1 to 4 also has a GCD of 1. Therefore, both are good. Therefore, the entire array is beautiful. Okay, similarly, 361 is good but not beautiful because the prefix 36 actually has 3 as a GCD, which is actually greater than the length of the prefix. Okay, length of the prefix is 2, GCD is 3. Therefore, it is not a good array. Hence, the entire array is not a beautiful array. Okay. Now, Mocha gives you the gift array A of n positive integers and she wants to know whether A could become beautiful by reordering the elements in A. It is allowed to keep the array A unchanged. Okay, so we just need to tell if the entire array can be rearranged in such an order that it is a beautiful array. Now, in order for the entire array to be beautiful, every prefix has to be good. For every prefix to be good, the first prefix which is of size 2. So let's say if you had an entire array, okay, and if you take the very first two elements, these two elements, okay, after reordering, the GCD of these should be less than equals to 2 because the length of the array is 2. Okay, and you want the GCD to be less than equal to their length. Okay, which actually means you need to figure out two elements in the entire array. Okay, any two elements whose GCD is either 1 or 2. Okay, because if this becomes a good prefix, okay, if this becomes a good prefix, the next prefix will also be good, because if GCD of first two elements is 2, GCD of next two elements will be either 2 or less than 2, not more than 2. Okay, so that is all you have to do. You just have to do two nested loops, figure out if there are any two values in the entire array whose GCD is actually less than equals to 2. If yes, then the answer is yes, otherwise no. That's it. I hope the logic is clear to everyone. I'll quickly show the code as well. Uh, okay. All right. So this is the code. Okay. All I'm actually doing is, okay. So all I'm doing is I scan the entire array. After that, I just have a nested loop in which for any two values, I am just checking if the GCD is less than equal to 2. Okay. If the GCD is less than equal to 2, then I say my flag is equals to 1 and see out yes. That's it. I hope this is clear to everyone. If yes, we can move forward to the next problem. All right, so you can look at the code from my summations as well, if instead of like not pausing the video here. All right, so let's move to the next problem. I think A was pretty easy, so let's not waste any time. Let's move to the next problem. It just says yes, Musa. All right, so problem 2. Serval has a string S that only consists of 0 and 1 of length n. The ith character of S is denoted as Si, where I is less than equals to 1, less than equals to n and greater than equal to 1. Serval can perform the following operation called inversion magic on the string. Choose a segment LR, okay, where L and R both are from 1 to n. Now, change Si from 1 to 0 if it was 1 or from 0 to 1 if it was 0. Okay, now, so we can actually perform this inversion once on any subsegment of this array. Okay, now a string is a palindrome. Now we want this entire string to be a palindrome. Okay, how can we make this palindrome? By performing this operation only once. Okay, that is what the problem is saying. So let's look at the example. Okay, so let's look at what the first example. If you see, this is already a palindrome. Since it is already a palindrome, since 1001, this is already a palindrome. 1 is equals to 1, 0 is equals to 0. It is already a palindrome. Therefore, the answer is yes. In the next one, if you see, it is 10010. Okay. Now, if you just take this subarray, sorry, if you take this subarray, sorry, not this subarray actually, this has to be changed. If you take, I'm confused, this subarray and inverse this actually becomes what? Am I wrong? I think no, you don't have to take this actually. Okay, let me just rub this. Okay, if you take this subarray, okay, after inversion, it will actually become 10101, which is actually a palindrome. Therefore, the answer can be yes. Similarly, for the next one, if you look at this one, there is no way you can take one subsegment, inverse it, like inverse as make an inversion of it, and even after that, it will become a palindrome. Therefore, the answer is no. Now, how to solve this problem? Okay, let's move to board, or let's do it here only. Okay, let's say we have a palindrome of some size. Let's say of length 5. And let's say we have 1 here and 0 here. Now, since both of these values are not equal, that means we will have to inverse either one of these values. Let's say every time we have to inverse, okay, we have to either inverse the left value or the right value, okay, because if we inverse both, nothing changes, okay, both will still remain different, okay, and we only need to inverse when they are different, okay. So let's say every time we find one unmatching pair, we actually inverse the left part. So let's say this has to be inversed. So let's write the indexes 1, 2, 3, 4 and 5. Let's say the very first index had to be inversed. Okay, so we actually mark the very first index that we have to inverse this. Let's come on to the second index. Let's say second index was this. Now again, second index and fourth index are different. That means either one of these needs to be inversed. And since we are actually noting only the left ones, okay, we will say number 2 also needs to be inversed. For number 3, any value will be work because it is in the middle. Okay, with this we actually say that value 1 and 2 needs to be inversed. So we inverse these values. What do we get after inversing these values? We get 0 1 1 1 0, which is a palindrome. Hence the answer for this would actually become yes. Okay, now let me just explain like why we are doing this. So let's say we had a bigger array now. We had a bigger string. Okay, let's say its first index was same 1 and 1. Let's say for the next one, this was 0, this was 1. So we will say second index, let me write indexes here. Second index needs to be inversed. Let's say third index was okay, no problem. Then let's say fourth index also was different. We will say fourth index also need to be inversed. So with this approach, we'll actually mark all the indexes that needs to be inversed. Okay, after that, what we will do is we will take all these. What we will do is we will actually say 2 is the start, 4 is the end of the subarray. And what we will do is we will take this entire subarray, okay, and inverse this. And after inversing, we'll again check if this is a palindrome. If this is a palindrome now, then the answer is yes. Otherwise, the answer is no. Why this works? Because we've actually found the shortest subarray, which we need to reverse. The shortest subarray, okay, we actually found the starting point and the ending point of the subarray, which is the shortest subarray, which we need to inverse in order to try to make this a palindrome. But if you see, while doing this, there are some indexes in the middle, like the index 3, which also got inversed. Since 3 also got inversed, this won't be a palindrome. Okay, but if this range had been a consistent range, if this had been 2, 3, 4, all the values of 2, 3 and 4 had been different, then the answer would have been a palindrome. Okay, so all we have to do is find the shortest subarray, which we need to inverse. Okay, and then check if it is a palindrome. If it is a palindrome, then the answer is yes. Otherwise, the answer is no. Okay, that's all you have to do. Let me show you the code as well. Okay. So yeah, this is the code. So what I'm actually doing here is, if you see, okay, so first I scan the entire array. Okay, after that, what I'm actually doing is I'm just checking for every index si is not equal to si minus si s of n minus I minus 1, which is if this is my string, if I'm checking for this one, then I'm checking it with this one. If this is equal to this one, then nothing. If they are not equal, then push that index into the vector. Okay, after pushing that index into the vector, I check if size of this vector is greater than 0. If size of this vector is greater than 0, that means I had to make an inversion. Okay, if it is greater than 0, then what I do is I take the first element of the vector and the last element. These two elements will actually tell me the size of the array, or the starting and the ending points of the array, subarray. Okay, what I do is I inverse the entire array. Okay, this is nothing but this is actually character notation of 0. In this part, what I'm actually doing is if si is 0, 1 minus 0 will actually give me 1. Then 0 plus 1 will actually become 1 in characters. If it was 1, Okay, then 1 minus 1 will actually give me 0, and this 0 in characters plus a numerical 0 will actually remain character 0 only. Okay, so if it was 0, then it turned to 1. If it was 1, then it turned to 0. Okay, so I'm inversing SI for that subarray, and then I'm just checking it again. If this array is a palindrome or not. If it is a palindrome now, okay, then I print yes, otherwise no. That's it. Alright, so that was all you had to do for problem B. Again, easy problem I would say. This is the code. Let me just remove this. This is the code if you want to see. And I think we can move forward to problem C. Alright, so C jaldi karo sir, wo nahi hua. Okay. C is a little tough compared to other problems. I can say that. Even I took some significant time. Alright, so yes sir, B was easy. Okay. Alright, so let's read C. The statement of C is a little confusing. It is a more like an implementation problem. That's why. Okay, so we'll first understand what the problem is trying to say, and then we will solve the problem. Okay. Alright, so the problem says that toxel-like arrays, before traveling to the Paldea region, Serval gave him an array A as a gift. This array has n pairwise distinct elements. Now, what does pairwise distinct really mean? Pairwise distinct actually means any value, any two values in the entire array, they are not same. Which means every value in this array is distinct. If I have 5 elements, all the 5 values will be distinct. No two values are same. That is what pairwise distinct means. In order to get more arrays, Toxel performed m operations with the initial array. In the ith operation, he modified the pith element of the I minus 1th array to vi. Okay, so let me explain this part. So what we actually have is, okay, we have three arrays. We have array A, we have array P, and array V. Okay, on my first operation, what I do is I take the first element of P, okay, and switch it. So let's say this is X. That means I have to go to the xth index of A and switch it with this V1. Switch it with V1. That is what the problem says. Okay. After doing that, I will get another array which I will say as A1. And then I'll do the same thing for A2 with A1 as the base array. Okay. I'll explain it again. I think I need something better for that. Just a second. Okay. So what we actually need to do is, let's say we had our array A. This is A0 right now. This A0, let's say, had some values, 5 values. Okay, and let's say we had P and V. Okay, this is P, this is V. Let's take the first example only. First example is 1, 2, 3. So we have 1, 2, 3 elements only. So let's take 3 elements. So I have 1, 2, and 3. Okay, and indexes of these are also 1, 2, and 3. Now, what are P and V? P and V are 1, 4, 2, 5. 1, 4, 2, 5. What it is actually saying is, in the first operation, in my first operation, I have to go to the first index and change the value to 4. So my array would actually become 4, 2, 3. I went to the first index, changed the value to 4. Change the value to 4. And this array I will say is A1. Now I'll do the same thing for the next operation, but with A1 as the base array. So I need to go to the second index. I have to go to the second index and change the value to 5. So second index actually has 2. I'll change the value to 5. Rest of the values will remain the same, which are 4 and 3. And this is A2. Now I've got 3 arrays. There were 2 operations. I've got 3 arrays. So if there were m operations, I'll get m plus 1 arrays, because I had 1 array initially. Now what they're actually saying in the problem is, so they are saying finally Toxel got m plus 1 arrays and denoted them as a0, a1 till am. That is what we have got. We have got a0, a1, a2, where m was 2. Okay. Now, Toxel defines its value as a number of distinct elements of the concatenation of ai and aj. Now, Toxel wonders what is the sum of values of all pairs. Please help him to calculate the answer. Basically, they are saying if you take any pair of two arrays, if I take these two arrays, what are all the values I have? I have 1, 2, 3. Then I have 4, 2, 3. 4, 2, 3. What all are distinct values in this? I have 1, 2, 3, and 4. So there are 4 distinct values actually. That means the value of this pair is 4. Similarly, if I take this pair, okay, what the value will be 2, 4, 2, 3, and 4, 5, and 3. Again, if I find out the distinct values, they are 2, 3, 4, and 5. So 4 different values. Similarly, one pair could be this one. And if you try to find out the distinct values in this, you will get 1, 2, 3, 4, 5, 3. Again, distinct in these are 1, 2, 3, 4, 5. So in total, if you see, there are 5 values. We need to find the sum of these. 4 plus 4 plus 5. 4 plus 4 plus 5, which actually makes 13. So 13 is the answer. Okay. So how do we really do this? Okay. Now let's try to think of this problem in a different way. Okay. So the problem was that we need to make all these arrays. Let's say we have already made these arrays. Okay. We need to make these arrays, and then for every pair of these arrays, we need to find how many distinct values they have and then count them. Okay. Let's forget about the distinct values. Let's see how many values they will actually have. So let's say there were m operations. Okay. If there were m operations, that means we had a0, a1, a2, so on till am, right? Which means we had what? M plus 1 arrays. Okay, and every array had how many values? N values. Now let's see how many pairs do we actually get out of these. First pair will be a0, a1. So we have a0, a1 as the very first pair. How many values do a0 have? N values. How many values do a1 has? N values. So how many values do they total have? In total they have 2 n values. Similarly, we will also have a pair of a0, a2. Again, a0 has n values, a2 has n values. In total they have 2 n values. I'm not counting the distinct values, I'm only counting the total number of values. Okay. Similarly, if you see, I will have a0, a3, so on till a0, am. And every one out of these will have 2n values. So if you see, these are what? M times of 2n. Okay. So we got m times for 2n. Then we will actually start our pairs from a1. So we'll have a pair from, can I zoom out? We'll have a pair from a1, sorry, a0. Now I need to jump one. So first I was taking a0, a1, then a0, a2, then a0, a3, so on. Now I'll start from a1. So I'll have what? a1, a2. Okay. a1, a3, a1, a4, so on. And every one of these will also have 2n values. And how many pairs will these be? These will be m minus 1 pairs. Similarly, if you go for the next one, you'll actually start with a2 for a3, then a2, a4, and so on. And these will be m minus 2 pairs. And every pair will have 2n values. So if you see, the number of total values that you will get will be m times 2n from this part plus m minus 1 times 2n from this part plus m minus 2 times from this part, so on till 1 time 2n for the last one. And what is the summation of these? If you see, the summation of these will be 2n times m plus m minus 1 plus m minus 2, so on till 1. which is nothing but 2n times m into m plus 1 by 2. And if you cross these two and these two, the total values that you will get will be n times m plus 1. So these are the total values that you actually get. But we are given, we need to find the distinct values on. So if you see, let's say if you had these two arrays, if you're considering these two values, if there was a value x here and a value x here, if x was present at this place and this place, the number of distinct values will decrease by 1 because x was present at two places. Okay. Similarly, if you say x was present here again, if x was present here again, now since there are three x's, you will see that when you are counting a0 with a1, x was counted twice, so you need to subtract 1. When you were taking array a0 and a2, x again was counted twice, so you need to subtract 1. And when you were taking a1 and a2, x again was counted twice, so you need to subtract 1. So in total, you had to subtract thrice. What if one more x comes in? If one more x comes in, this x might be counted with this one extra, this might be counted with this one, or this might be counted with this one. If you see the broader picture of this, there are four x's. And how many times do we have when they actually occur twice? That is 4c2. The number of ways in which we can select any two arrays which will have x. Since there were four arrays with x, 4c2. So for example, if there was some value x which was present in, let's say, y number of arrays, so you will do yc2. Okay. So what you actually need to do, so this is the total number of values. Out of these, you need to subtract all the values which are repeated. So let's say you had what? A1, A2, these are all the values, A3, so on, till some random number. A count of A1 was C1, count of A2 was C2, count of A3 was C3, count of A4 was C4, and so on. What you have to do is, for this, you have to find a C1, C2, 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 C3, C2, and so on. This C1, C2 will actually give me the number of times A1 was counted twice. And that is the number of times I have to subtract from this value. Similarly for this C2 as well. Similarly for this C3, C4, and so on. So for every value, I need to find their occurrences. Then I need to subtract all the time when they were counted twice, which I have to find by doing their combination too. That's all you have to do. Now, how do I really find the count of every value? Like, how did I really find the count of A1? That is something we need to do now. Is this part clear till now? The part where I count all the values and the part where I tell how many values are counted twice. Can you explain nmm minus 1? No, it is m plus 1 actually, not minus 1. Yeah, I can explain that. If I had a0 array that had n values, a1 array again had n values, a2 array again had n values. So every array had n values. If I took the very first pair of arrays, which is a0, a1, a0 had n values and a1 also had n values. In total, they had 2n values. Similarly, my next pair will be a0, a2, which again will have 2n values. Next pair will be a0, a3, which again will have 2n values. In total, with a0, there will be m pairs. Okay, because there are m arrays after that. This is, yeah. Okay, so if you see the total number of values, these pairs will give me will be m times 2n. Similarly, if you try to count all the pairs with a1, a1, a2, a1, a3, a1, a4, there will be m minus 1 pairs. Because the last pair is a1, am, and we started with a2. So m minus 1 pairs. And in every pair we had 2n values. So total values will be m minus 1 times 2n. Similarly, from a2 also m minus 2 times 2n and so on till 1 times 2n. This will go. Okay, and then if I try to find the summation of all these values, 2n is common, so I bring out 2n. I have m plus m minus 1 till 1. This is nothing but m into m plus 1 by 2. and this becomes n times m plus 1. I hope this is clear now. Okay. And the other part was counting all the repetitive accounts. Okay, that is also done. Now, how do we really find the count of A1, A2 and so on? That is something we need to discuss. Now, how we can do is, let's say we had array A0, it had some values. Okay, can you explain the combinatorics parts? Okay, I'll explain it. Let's say X was present here also, X was present here also, X was present here also, and X was present here also. X was present at 4 different places in these 4 arrays. When we took a pair of A0, A1, we actually said that one value was present here, one value was present here. But if you actually see, there were two values, like there was one value only at 2 places. So we had to count it once only, but we counted it twice. So we need to subtract that by 1. So because of these two x's, I had to subtract 1. Then again, if I took a pair of A0, A2, then also I'll have to subtract 1 because x is here also and x is here also. Again, if I took a pair of A0 and A3, again I'll have to subtract 1 because x is here also and x is here also. Similarly, if I took A1, A2, then also I'll have to subtract because x is here also and here also. So in short, if you see, x was present at 4 places, and in total there are 4 C2 ways in which I can actually take two arrays which will have x's and will be counted twice. So I need to subtract it that many number of times. In order to remove all the extra times I counted x, because in one time I was taking two arrays. Okay, so I need to find all the ways in which I'm taking two arrays which have x in them, which I can only do by finding all the count of arrays which had x once. Yeah, Rohit says got it. Okay, cool. Okay, so now the last part is how to actually find the count of any particular value. Let's say I had x, y, and z. Okay, let's take three values only. Okay, let's say in A1, when A1 came, I switched y to some other value. Let's say y was switched to what? Uh, Alpha, let's say. Y was switched to alpha. Okay, and I have x and z. I will say y came once only. But how do I really say that? I will actually say that x started from 0, y also started from 0, and z also started from 0. Now, when I say I have to change my second position with alpha, what I'm actually saying is when alpha comes, see from where did y start? Y started from 0, and right now I'm at operation 1. That means the total occurrence of this is 1 minus 0. Mark this for y, that y came 1 minus 0 times. Similarly, let's say I would have done it like some more times, let's say, and then for x, for some, let's say a5, let's say, at x, I had to make beta. I had to replace it with beta. So my array would become beta, alpha, and z. For alpha, I have already marked the starting point as 1. Okay. When I came to this point, I will say, I have to replace x with beta. I will first have to update the count of x. My x will say I started from 0. I started from 0. So I started from 0, but I'm getting removed at 5th. So 5 minus 0 will be the count of x. And I need to say that beta is also starting. From where is beta starting? Beta is starting from 5. So essentially what I'm actually saying is, let me just, what I'm actually saying is, I'll have two maps. One map, I can actually do it with arrays as well, but I thought like map is easier in this case since constraints are smaller. Okay, what I'll do is, I'll say one map as occurrence and one map as start. Okay, right now there is nothing in occurrence, and in the initial phase, my start will say x started from 0, y started from 0, and z started from 0. And let's say the first operation is mark the second index with alpha. Sorry, with alpha. What I will do is, since my second index is being removed, I will first say what was already present at y. At y, at second index, y was present. From where did it really start? It started from 0. So I will say occurrence of y becomes 1 minus 0. Okay, and then I will say alpha is starting at 1 and y is removed from here. Now again, let's say at fifth operation, there were some more operations, and after that, in fifth operation, I said that at first index put beta. So what I'll say it, at first index I had x. Where did x really start? X started from 0. So at x I will say, right now I'm at fifth operation and it started from 0. So 5 minus 0 is 5, which means says that x has already occurred 5 times. Then I remove x from the start array, and then I say beta started from fifth. And if you keep on going till the last operation, in the end this occur map will actually contain all the occurrences of every value. And then since I have all the occurrences of every value, I'll do this part in which I'm actually finding all the duplicates which were counted, and then remove all these values from this. Okay, I hope this is clear. Let me show the code as well. Maybe this will get a little more clear with that. Let me read the chart. What is your opinion on Google Code Jam and Kickstart getting discontinued? We can't help it. Like, it's okay if it's discontinuing. I wish it wasn't, but yeah. Okay. Can you explain the? Okay. Yes, sir. Clear. Okay. Cool. Let me show you the code as well. All right. So this is the code. Again, I'll just quickly explain like what is there in this one. So as I said, I have two arrays or two maps. One is occur, and one is start. Okay, I've actually done everything as one based indexing. I was explaining at zero based indexing, but now, okay, yeah, but now in the code I've actually done it one based indexing. Okay, all right. So what I'm actually doing here is first I scanned the entire array, and while scanning, I marked the start of every element as 0. Okay, that they're actually starting at 0th index. Okay, or A0. Okay, now at every operation, sorry, yeah, at every operation, when I scan the operation for P1 for value vi, what I say is I first read the old value. Old value will be pi is the index that I need to change. So I go to the array, ask what is the value present at that index. That is my old value. Then what I say is for occur, okay, I have to count the occurrence of old value now. For occur, I is the ith operation right now which I'm at. Start will tell me from which index this old value is coming from. So I minus start old will actually give me the occurrence of this I till now. That I have to add in occur old value. Then I have to erase this old value from start because it no longer exists in the new array. Okay, and then after that, I have to update my new array, put vi, which is the new value in the array, and then after that, I have to say this vi, this vi started at ith index, so mark it in the start map. Using this, I will have all the occurrences. Okay, after doing that, what am I just doing? Again, I'm starting a for loop for all the remaining values in the occurrence in the start. Sorry, for all the remaining values in the start because they are coming from the starting only. So I need to count those values as well. So I add the occurrences of those values as well, and then after that, this is the answer. The answer which does not count the distinct values. Okay, it only counts the number of values. Okay, it doesn't take in consideration that were there distinct values or not, which was n times m plus 1, which we already counted. Okay, and then I just subtract nc2. Okay, if like let's say it dot second is x and I had to find xc2. Xc2 is nothing but x factorial upon x minus 2 factorial times 2 factorial, which is nothing but x times x minus 1 by 2, which is what I'm doing. It dot second times it dot second minus 1 by 2. This I'm subtracting from answer for every occurrence. Okay, and then I just print out the answer. That's it. Okay, Akash says भैया occurrence वाला समझ नहीं आया. Okay, occurrence वाला. Okay, so what I'm actually doing is I'll again go back only. Hmm, just a second. Okay, what I'm actually doing for occurrences, yeah. let's say the first array had x, y, and z. Since the first array had x, y, and z, I will say my x is starting from 0, y is starting from 0, and z is also starting from 0. Okay, and these are removed. This is also removed. Okay, now my operation comes, which says my first operation says that I need to replace my second index with alpha. Okay, second index with alpha. First, I need to see what value was already present at second index. Y was present. So I'll say Y occurred from what is the current array I'm at. I'm at the first array, which is the first operation. Y occurred till 1 and it started from 0. So 1 minus 0. Now remove Y. Remove Y because it no longer exists in the array and mark the occurrence of alpha. Alpha is starting from 1. With this, we keep on going. Let's say at the fifth operation, we say change the first value with beta. So the very first thing that I'll do is first see which value is present at the first index. At first index, x is present. So how many times that x come? X, we are at fifth operation. So 5 minus, it started from 0. 5 minus 0. Now remove x from the start map because it no longer exists in the array. And then mark beta as 5 because it started from the fifth value. And that's it. That is how you actually find the occurrence. Okay, and in the end, when all the operations are done, do the same thing one more time for all the values present in start. Okay, all right, so that is all we had to do for this one. I hope this problem is clear to everyone. It's a very good problem, a very good implementation problem involving few of the things. Vishway says for auto start till occur IT plus minus. Yeah, can you explain this? Yeah, this I'm actually doing at the end. Okay, when I'm done with all the operations, since I'm done with all the operations, right now if I had to do one more operation, that would be a of m plus 1. But I don't have to do that. But I still need to find all the values which are still present in the start. So what I'm doing is taking every value. So if I write for auto IT start, this actually means I'm going to iterate for every value in the start. It dot first will be z and it dot second will be the value which is 0. And that is how I'll iterate the entire map. Okay, while iterating, I'll say right now I'm at m plus 1th operation. Although I don't have to do this operation, but I am at m plus 1th operation. And these are the indexes where I started. So I have to subtract those indexes. That will be the occurrence for that particular value. So that is what I'm doing. All right. So I hope this is clear to everyone. And I think we can end the stream as well. It was a long stream of 50 minutes. I think major times went in problem C only, but I think I explained C pretty well. So yeah, that's it. I think let's go to Codeforces again. So we solved problem A, B, and C. I hope it is clear to everyone. And the next contest is on what? When? 27th at 8 only. It's a 3-hour contest. I didn't know about that. Okay. Thanks for that. Okay. Actually, like I have a meeting from 9:30 to 10 on 27th, which is Monday actually. So I won't participate in the contest officially, but yeah, I'll solve the contest and come for a stream after the contest. Okay. All right. So I hope this is clear to everyone. And yeah, that's it. Okay, do like the stream, guys. I only see 18 likes for the stream. Do like the stream. Also, subscribe to the channel. Tell your friends about the channel as well because I come live after every contest, almost every contest. I try to come live for every contest. First time in live contest explanation. Best experience. Thank you, Saurabh. Tejas says yes. Can you make a playlist of ladder problems? I am thinking about that. Hopefully, I'll make it soon. I am actually caught up with my work lately. That's why I'm not able to make that playlist. I have been thinking about that playlist. Okay. Alright, do like the stream, subscribe to the channel, tell your friends about it, and that's it. How to solve problem C in contest. Just practice, do Codeforces ladder for problem C. It will definitely help you. Okay, cool. That's it.